So cute.
Exactly. No one talk. Be honest, I know this kind of problem does show up quite regularly on the AP test, either in the multiple choice or the FRQ section. I wouldn't call it a high priority, it's kind of medium. It's not my favorite because it takes a lot of writing if it's a multiple choice, if it's an FRQ. But it is a good one to go through the process because it does show up regularly enough. Limit at x equal 2, I look at my golden notes and remember that to find a limit, I first look for x approaching infinity. This does not do that. I then look to factor and divide. This one I can do that, so that's the first thing I'm going to do. So I look at f of x and I rewrite it. So I am simply following the box on the golden notes. Does anyone need me to show you the box I'm using on the golden notes? If you do, just wave. So look right here. Limits. Right there. Well, actually it goes one down further, sorry.
So
That's the little section on limits right there.
that applies to the, oh man, I'm saying this so wrong. But when it has like multiple different
Piecewise, you mean?
piecewise functions.
Yeah, it doesn't matter the type of function, the rule still works.
Okay.
So I first notice that x is not approaching infinity, so I skip step 1. You with me? Step 2 says factor and divide. That's what I'm doing now. So I've done that. Okay, other questions? Please, Carla.
Like when I was solving it, like I did all of this, but I like could not remember for one me if like at a limit, if it has to like if the limit from the right and the left have to equal, but I couldn't remember if it also needed to like that point needed to equal that value, like at the specific point. But I knew it wasn't continuous and I knew it wasn't differentiable, so I just kind of, and there was no like none of the above, so I just said one only.
I understand.
Is that a
It's
should I
not-
give myself that point?
Oh no, give yourself that point. Because it's enough logic. Like, I totally get the idea that we're practicing and like, well, should I give you my point? Not. You can give yourself that one, that's fine. Because you're using pretty good logic there. The pieces you're missing, well, let's keep going. So we're good to hear? Point from Carly? Okay, cool. Next box I need to use, well, to find the limit now I just check left and right. So if x is really close to 2, so I'm finding this, the limit, as x approaches 2 from the left. You don't have to do the writing on a multiple choice. I'm showing you the writing as though it were an FRQ to give you some practice. Hands up, who knows it? What's the limit as x approaches 2 from the left? Let's go, Caleb.
I don't think I can.
Point for a good try. Dylan.
4.
I pointed at Isaac, sorry. Go ahead, Dylan.
Oh, I said 4.
4. Yeah, look. When x is almost 2, you should be looking here. So x is almost 2, you look there. When x is almost 2, this is perfectly 1. Perfectly 1. The only time that isn't perfectly 1 is when x is exactly 2. So this value is 4. This value is also 4. Again, because we're focused on concepts, like Carly said, yeah, she'll get a point for this on the practice test, but more important to her is the idea of like, I can understand this better because on an FRQ I probably wouldn't, because I wouldn't have enough things written down. If the thing you forgot is, and it's right here on the golden notes, if the left and right limits match, that's the value of the overall limit. If the left and right limits don't match, then the limit does not exist. So that's that third box. But then your next question leads right into the next box, right here. That's why they're grouped together on the sheet. continuous. For a function to be continuous, the left and right limits must match, and the value of the function must be the same as well. So that's why we know, hands up please, what goes right here? Hands, show me hands. What goes there? Go to Josh. How many agree? Point. 2 for Josh. So now we know it's not continuous. It does have a limit. It's not continuous, it's not differentiable. Please.
So for either 2 or 3 to be true, if the one before it has to be true, so there has to be a limit for it to be continuous, so it has to be continuous and a limit for it to be differentiable.
Mm-hmm.
So like B and C just will never be the right answer.
Correct. Well said.
If it has a corner, it's still continuous, but it's not differentiable, right?
Correct. And corners occur at the junction of a piecewise, like the transition point. That's where you'll see corners for our class. Other than the absolute value function can have a corner.
Is there always going to be a limit on a graph unless it's like vertical asymptote?
No, remember, look at your golden notes. Actually doesn't say this, but I'll just help. The box that talks about continuous, if you have a removable discontinuity, I have to go back and study the definitions again because this just does not get tested that often. Removable discontinuity occurs when the left and right limits match, but the value of the function is different. So that's not, I mean, there's a limit exists there. But if you have a piecewise function with a jump, the left and right limits don't match and there's no limit. So that's not a vertical asymptote. Vertical asymptote, of course, the limit doesn't exist either.
Can we like pretend that it would be continuous and then go through the problem to see if it would be differentiable? Because like, I'm not quite sure how to.
Please watch the payment here.
Oh, wow.
You ready?
Come on, look good.
2, 3, 4, 5.
Okay.
Oh my goodness, this is a quarter.
Yeah. Look, I won't do that every single time, but I want to do it the first time because that's exactly your mindset. Like that's what I'm trying to get all of you to do is have the right mindset. And Caleb's thought is perfect. It's like, hey, I get this one, but I know I'm going to run into one where I've got to do more. It's a little hard to show you on this particular problem. It would be better to show you on a different one. Now I gotta remember which one it is. Oh, I know. It's an FRQ. It's 2003. Hold on.